So today we are starting a lesson called electric charges and fields. In that, we today in this video we learn about the charges, about the field, about the properties of charge, methods of charging. If possible, we also learn the Coulomb's law. So first we learn about what is charge. What is a charge? Basically, a charge is a property of any matter. It is a property. It is generally it is represented as Q. It is a property of matter. It is a property of matter by of matter that produces or we can say and experiences also an electric field and a magnetic field. Yes, it is also produces or experiences the electric field and magnetic field. It is generally represented as Q. It is the property of matter which produces and experiences the uh, electric field and magnetic field. Then, what do you mean by field? What do you mean by field? Field, in general words, a field is a space. In general words, the field means it is a space which is under the control, or we can say it experiences the space around the charge or a magnet. If the space around the charge is known as an electric field, if the space around the magnet is called a magnetic field. It experiences the magnetic attraction or repulsion, magnetic force. The electric field, in electric field, there will be an experience of the force of attraction or repulsion by the charges, right? It is a space by which any material can experience force of attraction or repulsion. For example, let us take an electric field. In electric field, the space around an charge, right? Around a charge experiences the force of attraction or repulsion. If there is a positive charge here, suppose this is a field, electric field. If we keep minus charge Q here, so it will attract. Both the charges will come closer. So minus Q will experiences the electric field around the plus Q, right? Or if we take magnetic field, say it is also same like that, like an electric field. If an magnet is kept here, north and south end, if we bring a like pole to nearer to first magnet, suppose it is south, it is north, it both of them experiences the uh, magnetic field by going away, right? So these are called as the fields. Then next we learn about the properties of charge. So there are three properties of charges. One is charge is additive in nature. Additive in nature. Charge is uh, quantized, and the last one is charge is conserved, right? So let us know one by one. First one is charge is additive in nature. What do you mean by additive? Additive means summation or addition. Charges are additive. If we add the two charges or more than two charges, they may be added, right, and subtracted, right? So this is the meaning of additive. If we take a field, electric field, the minimum charges in an electric field will be always 2. The minimum charges in electric field will be always 2. So if we consider a group of charges, means if we consider a group of charges in an electric field, the summation of all the charges will become q1, q2 plus q3 plus so on. They may be additive, right? They are additive. So charge will have only the magnitude. It has magnitude, no direction, right? No direction. So it can be, not it can be, it is scalar. It is scalar quantity. Scalar quantity. So next we will be understanding the charge is quantized. Charge is quantized means charge is quantized means there if a body contains some charge, means it will be containing only like numbers, whole numbers, like a zero charge means it is neutral charge. Charge 1, it will be always like multiple of the whole charge on body will be the multiply of uh, a universal charge value, that is E. E means 1.6 into 10 power minus 19 coulomb. This is a universal charge value. Here it will be a whole number, multiplication of a whole number, we can say, right? Yeah, it may be a negative or it may be positive, because electron is a negative, right? So if we consider the negative charge, we need not to put here plus, I mean plus or minus. So the charge on a body may be positive, maybe negative. So by combining both of them, we can write charge on a body is equals to plus or minus Ne, plus or minus Ne. this this is the important formula for competitive exams. So next is, yeah, and here the charge cannot be written in the fraction decimal. If a body contains a charge of 1 by 2 of charge of electron, no, this is wrong. Charge cannot be in terms of fraction or decimal. This is a fraction, right? If a body contains um, 2 times the electron's charge, it may be, it is correct, maybe it is correct. Next, the third property, charge is conserved. For example, if yeah, we have all learned that mass mass is mass is neither be created nor be destroyed, but it can be transformed transformed from one state to another state, or we can say that one energy, yeah, we can say that it applies for all one state, yeah, one state to another state. So we have learned that mass, which can neither be created nor be destroyed, means we cannot create the mass or we cannot destroy the mass. We can just transfer. For example, if we in our daily routine, if in our body, if we daily eat one 5 kgs or 2 kgs of food daily, if we eat 2 kgs of food one day, then it will consume while doing the work, right? While doing the work, here the food is a form of energy which is converted into our energy. That energy is converted into our um mechanical work, right? Like we can do the works from that energy. So this is also like that. The charge cannot be created. The total charge on the earth, inside the earth and on the earth, is always the same and will be same forever, right? So so the charge will be always conserved. We can never add some charges into earth. We can never take out from charges from the earth, right? This is the charge. Yeah, we can write here law of conservation of charge, of conservation of charge, right? Next, we learn about methods of charging. Next, we learn about methods of charging. There are 3 methods of charging: by friction, by conduction, and by induction. So first we learn about by friction. By friction. By friction. This means the charges is transferred or a neutral body can be charged by the friction, which means if we rub, for example, if we rub a a glass rod, with a silk, the glass rod which will be of neutral gets positive charge while the silk will get negative charge. So here there will be a physical physical contact of the two properties to transfer the charge from one body to another body. Here the glass rod will be initially neutral when it is rubbed with the silk. The glass rod will get positive charge and the silk will get negative charge. Then we will learn about by conduction. Conduction is similar to the friction, but here there will be similar to friction means there will be a uh, physical attachment to the two bodies or two properties, but there will be no friction. So without friction without friction there will be charging of a neutral body from a charged body right? So here it was by conduction. Next we will move on by induction. By induction we learn the process of charging, but here the two bodies are not physically uh, brought not physically attached, or it is just brought nearer, like a rod, a positively charged rod brought near to the neutral it if neutral sphere means it contains the number of both electrons and protons, but their number will be same. Their number will be same, right? So if we brought a positively charged rod to neutral body, then the neutral body will get the negative charge, or the opposite charge which is opposite to the rod will get nearer to the rod, will accumulate nearer to the rod, and positive charge will accommodate to the opposite side of the rod. So this is induction, right? So we will continue the Coulomb's law in next video. So thank you.